This is video 4 for lesson 2 in unit 6 of Chem 1. So we have looked at our first example of balancing chemical equations, and here we use this little chart. You may like this, you may not. So in our second example, I'm not going to use the chart, but I'm just going to talk through a logical or just by inspection. So I have carbon, hydrogen, and oxygen. So I know that I saved H and O for last, so I'm going to look at carbon first. So if I look and see, I have 2 carbons here, I have 1 carbon over here. So I'm going to put a 2 in front of here to give me 2 carbons. So my carbons are balanced. Then I'm going to do my H's. I have 8 H's over here. I have 2 over here. So what number times 2 would give me 8? So I can put a 4 there. 4 times 2 is 8. So now my H's are balanced. Now I have to do my O's. So I've completed this side over here. So I'm going to count the O's over here and see if I can put a number here to balance out my O's. So I have 2 times 2, which is 4, and 4 times 1, which is 4. So 4 plus 4 gives me 8 O's. So I can put a 4 here to give me 8 O's. Now I want to double check. 2 C's, 2 C's, 8 H's, 4 times 2 is 8 H's. 8 oxygens, I have 4 here and 4 here. That one is checked. Go ahead and pause the video and try number 3 and then unpause and you can check to see if you got the right answer. So, pause. All right, welcome back. So let's see how well we did. So if we look, we have 2 B's on this side. I'm going to put a 2 in front of here to give me 2 B's on this side. My carbons, which are also nonmetals, are already balanced, so we're good there. And now if I look at my chlorines, I have 6 here. To get 6 here, I'm going to have to put a 3 in front of this chlorine because 3 times 2 is 6, 2 times 3 is 6. So my B's, my C's, and my Cl's are balanced. Now I have to look at oxygen. I have 3 oxygens here, but I only have 1 here. So that means I have to put a 3 here. But that also, unfortunately, changes my carbons to 3, which we can fix by putting a 3 there. So if I look now, 2 B's, 2 B's, 3 O's, 3 O's, 3 C's, 3 C's, 6 Cl's, 6 Cl's, I'm done. On the next page, we have number 4. So I'd like you to go ahead and try number 4 and then unpause and we'll check our answer together. So go ahead and pause the video. Welcome back. So with this one, we have P, H, and O. So remember that we saved the H and the O for last, so we're going to balance the P's first. So we have 1 P on the reactant side, and we have 4 P's on this side. So I have to put a coefficient of 4 over here. So my P's are balanced. Now I move on to the H's. 4 times 3 gives me 12 H's on this side. I have 2 on this side, but I can put a number in front of here. So what times 2 is equal to our 12 that we need? 6. 6 times 2 is 12. So my P's and my H's are balanced. Now I have to find what I put in front of the O. I don't want to put anything here because if I put anything here, that's going to change my P's and then change my H's again. So I'm going to count how many O's we have on this side. I have 10 here and 6. So I have 16 O's. What number times 2 is equal to 16? That would be 8. And again, we always check to make sure it's in lowest terms too. 4, 8, 1, and 6 are in lowest terms. And now we can double check. 4 P's, P4, that's 4 P's. 12 H's, 6 times 2 is 12 H's. 16 O's, there's 10 plus 6 from the water gives us 16. We're done. Now, number 5, we have an issue. If you don't know what C8H18 is, you really like that compound because that's gasoline. It's what you put in your car so you can drive. So this plus oxygen gives us carbon dioxide and water. This is how an internal combustion engine works. So with this, if we want to balance this one, we have 8 C's. So I'm going to put an 8 in front of CO2. I have 18 H's. So I have to think, what times 2 is equal to 18? And that would be 9. But now, if I count out how many oxygens I have 8 times 2, 16, 9 times 1. That gives me 25 oxygen. I can't put a whole number here to give me 25. So we have what is called an odd-even situation. We have an odd number of oxygens on this side, and we have an even number on this side. So the easiest way to get rid of an odd number is to multiply it by 2. So what we're going to do is we're going to multiply completed coefficients by 2. So we have completed everything but this oxygen right here. So I'm going to make this a 2, this a 16, and this an 18. Since I multiply both of these by 2, that gives me 50 oxygen now. So it gives me 16 times 2, 32, plus 18 times 1, 18. That equals 50. Now, I can easily put a number in front of here. What number times 2 is equal to 50? That would be 25. So these are still in lowest terms. So 2 times 8 is 16 O's. 16 times 1 is 16. Carbons, sorry. So we have 16 carbons on both sides. 2 times 18 is 36 H's. 18 times 2 is 36. We have 25 times 2, 50 oxygens. And then we have shown that we have 32 plus 18, which is 50 oxygens. So anytime you do that, just cover up the one that you didn't do, multiply these by 2, and we end up with getting rid of that odd number. And helpful is to do these in pencil, not pen. That way you can erase. So our last example problem is here. And this one illustrates that we can use, or these ones have polyatomics that appear on both sides. So you can see that we have an SO4 group, a sulfate here, and that appears over here as an SO4. So we can treat that like one thing. The same thing with PO4. So when we look at this, we look at the calciums first. So we have calcium, 1 here, and 3 here. So I'm going to put a 3 in front of here. Then I'm going to move to the barium because calcium and barium are both metals. I have 3 bariums on this side. So to get 3 bariums on this side, I'm going to put a 3 there. But if we look, we have an SO4 group here and an SO4 group here. With the coefficient of 3 in front of it, that means that we have 3 SO4 groups here and 3 SO4 groups here. So we're good. The PO4 appears on both sides, and there's a coefficient of 2. So that means we have 2 PO4 groups and 2 PO4 groups as written. So this one is balanced.